Just like we can calculate the pH of polyprotic acids, we can also calculate the pH of polyprotic bases. In this problem, we will find the concentrations of all species present in a solution of carbonate and the pH. To begin, we break down the process into two reactions. The first is carbonate acting as a weak base. To find the Kb of the reaction, we use a relationship between Ka, Kb, and Kw, and the Ka of hydrogen carbonate, which is given in table 14.3. Once we have Kb, we can set up a rice chart and solve for the concentrations just like for polyprotic acids. In this case, X represents the concentration of hydrogen carbonate and hydroxide, while 1 minus X is the concentration of carbonate. We deal with the second reaction much like the first, except the base is now hydrogen carbonate. Using the Ka of carbonic acid, which is also in table 14.3, we can find the Kb of hydrogen carbonate. Setting up the rice chart, the only difference is there's already hydroxide in solution, where the initial amount X is the concentration we calculated in the last part. Here Y is the concentration of carbonic acid. Finally, we can find the pH by calculating the pOH first. Using a relationship between pH and pOH, we see the pH is 12.11. As a recap, we calculated the concentrations of carbonate, hydrogen carbonate, carbonic acid, and hydroxide to find the pH. Notice that although the concentration of hydrogen carbonate is X minus Y, and the concentration of hydroxide is X plus Y, Y is so small compared to X that it's insignificant and the concentrations are just the same. Solving this problem, we saw that finding the pH of solutions of polyprotic bases is really the same process to find polyprotic acids, just with Kb instead of Ka, and finding pOH first instead of pH directly.